absolute, relative, and percentage errors. Error is the amount of uncertainty that is present in the measurement. It is the difference between the measured value and the true value. So, it can be positive or negative. Suppose the true length of a body is 2.5 centimeters. It is measured as 2.7 centimeters. Then the error is plus 0.2 centimeters. If it is measured as 2.2 centimeters, then the error is minus 0.3 centimeters. The same error can be expressed in different ways as an absolute error, a relative error, or a percentage error. Suppose measuring the same physical quantity multiple times gives the values A1, A2, A3, and so on till AN. The arithmetic mean of these values is taken as the best approximation for the measurement under the given conditions. It is reasonable to suppose that individual measurements are as likely to overestimate the true value as to underestimate the true value of the quantity. Hence, the mean of A is equal to the summation of AI, where I runs from 1 to n divided by n. In the absence of any other method of knowing the true value, we consider arithmetic mean as the true value. The magnitude of the difference between the individual measurement and the true value of the quantity is called the absolute error of the measurement. This is denoted by the modulus of delta A. Then the errors in the individual measurement values for the true value are delta A1 is equal to A1 minus A mean. Delta A2 is equal to A2 minus A mean. And so on. Delta AN is equal to AN minus A mean. The delta A calculated is positive in some cases and negative in some other cases. But absolute error will always be positive. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error of the value of the physical quantity A. It is represented by delta A mean. Thus, delta A mean is equal to summation I is equal to 1 to n modulus delta AI by n. If we do a single measurement, the value we get most likely lies in the range A mean plus or minus delta A mean. That is, A is equal to A mean plus or minus delta A mean. That is, A is likely to lie between A mean minus delta A mean and A mean plus delta A mean. Instead of the absolute error, we often use the relative error or the percentage error. Relative error is the ratio of the mean absolute error, delta A mean and mean value of A mean. When the relative error is expressed as percent, it is called the percentage error, represented with del A. Thus, percentage error del A is equal to delta A mean by A mean into 100. Suppose 10 measurements of a given quantity are as shown. Their arithmetic mean is 1.49 seconds and the absolute error for each measurement is as shown. Mean of absolute errors is 0.03 seconds after rounding off up to 2 decimal places. Relative error of the experiment is 0.03 divided by 1.49, that is equal to 0.02. Percentage error is 2.0.